The next protein assay we're going to be talking about is popularly known as the Lowry Assay. This assay receives its name after the scientist who developed it in 1951, Oliver Lowry. The Lowry method is also known as the alkaline copper reduction assay. As the name suggests, this assay is based on the known reaction that happens between copper and proteins in an alkaline medium where copper is reduced. Once copper is reduced, it's going to interact with the Folin-Ciocalteu reagent, which is also reduced, shifting its peak absorbance to 750 nanometers. To perform the Lowry assay, the first step is to prepare the Lowry reagent, which should always be prepared fresh from an alkaline stock solution and a copper sulfate solution. Once you have that ready, you're going to mix it with your samples, incubate it at room temperature, and then you can add the Folin-Ciocalteu reagent, mix it again, let it incubate at room temperature once more, then you're ready to transfer it to a cuvette and measure the absorbance at 750 nanometers. At that point, you can use those absorbance measurements to interpolate your data from a standard curve using a logarithm methodology. To perform your Lowry assay, in addition to having your test samples, your blanks, and your standards, you're also going to need to have either a spectrophotometer or a microplate reader together with the appropriate cuvettes or plates. You will also need to have those 3 stock solutions that we mentioned earlier. Now, if you decide to run your assay on cuvettes, you're going to need to use 200 microliters of sample per cuvette, and if you run it on microplates, you're going to need 40 microliters of sample per well. Now again, remember that right now we're not taking into account those 3 technical replicates that you should always prepare. This assay has intrinsic variability to it because the Folin-Ciocalteu reagent binds not only to several amino acids as well as to the copper-amide bond. This assay is also not compatible to the presence of detergents and salts. For a complete list of reagent compatibility, please refer to the datasheet of your kit or to the references in our summary at the end of this course. The Lowry assay is fairly accurate and it can be extremely sensitive, especially when used on its original format that has a dynamic range of 5 to 100 micrograms per milliliter. If you'd like to expand that dynamic range, you can adjust the ratio of dye per sample volume, pushing that limit to 200 to 2000 micrograms per milliliter, which obviously compromises sensitivity. Now, this assay is labor-intensive, it's time-consuming, and therefore does not have a very big throughput. It is also a little bit on the expensive side. The conjunction of all of that is the reason why this assay was largely replaced by the BCA assay. If you choose to prepare your Lowry assay on a plate, you're going to save on sample volume, but you're going to compromise on sensitivity. If your plate reader does not have those wavelengths that we previously suggest, you can always use the range of 650 to 750 nanometers without severely compromising the sensitivity. Now remember that this assay involves the preparation of delicate solutions with reduced shelf life, so consider using a commercially available kit if you're going to perform the Lowry assay. Also, don't forget that this is not an endpoint assay, meaning that the reaction never stops happening, so it's in constant change. Therefore, you want to either stagger your cuvettes or spread your samples across the plate and make sure that you read all of your samples within a 10-minute interval. For more information, please make sure to watch our best practices lesson of this course, since it has a lot of important information on how to prepare the standard curve as well as on how to analyze your data.